Hello class, these are our notes for Algebra 1, section 412, piecewise functions. So a piecewise function let's go ahead and get our pen here, has different descriptions or rules for different parts of its domain. So now we're going to read through and consider the following function. So for example 1, function f gives the train fare in dollars for a child who is t years old based on these rules. So it is free for children under 5, $5 for children who are at least 5 but younger than 11, $7 for children who are at least 11 but younger than 16. So, I mean, this to me is definitely a real life thing, right? Like we often find that there's things like this that are free for kids when they're a certain age, a reduced rate when they're younger, and then maybe when they're older, they pay an adult fare. So this is a really common real life thing. So let's see if we can figure out how to do this. So it seems like we've got 3 different rules for the function. So the first rule is that it's free. So basically like they're saying the output is 0. So y equals 0. And that is when children are under 5. So t is less than 5. Right? But also, like, kids can't be negative numbers, so we would have to have 0 is less than or equal to t, or maybe just 0 less than t, because if it's just 0, you're not taking a kid anyway. So for the next one, they're saying, well, it's going to cost $5, so my output is $5. So y equals $5, but that's for kids that are at least 5, so it could be equal to 5, but younger than 11. And so the really kind of cool part here is that it's interesting, less than 11. I can't have 2 different answers for 5, right? Like I have to know how much money to pay for my kid when they're equal to 5. And so you'll notice like we have a less than or equal to 5 right here, but this is a younger than 5 right here. So if your kid is 5, you're paying $5. You're not getting away with the free. Right? So we have to be really careful when we think about what does at least mean. Younger than means I'd have a less than, but at least means I could be 11 and pay that much. So the final part of this function then is that it is $7. So our y value equals $7. Let me get my pen back here. For at least 11, so 11 less than or equal to t, and then on up to younger than 16. So it's really weird to have it written in 3 different parts like this, right? The way we would normally notate function notation for piecewise is we would say f of x equals, and then we're just going to write down those different y values. It could be 0 if 0 less than t less than 5, 5 if 5 less than or equal to t less than or 11, and then 7 if 11 is less than or equal to t, which is less than 16. So I think the first time you write piecewise functions, the first way we wrote it really makes more sense, thinking about like, what is my function equal to? What is my output? When is that happening? But then we can really see the elegance here of using this bracket to kind of like group it all together and say f of x is all of these different things, but on these different parts of the domain. So now we're going to go ahead and try and graph this piecewise function. So this is always really tricky for students. So I have one thing going on when it's between 0 and 5. So let's go ahead and count off and figure out where 5 is. 1, 2, 3, 4, 5. So 5 is right here. And then from 5 to 11, we have something going on. 6, 7, 8, 9, 10, 11. And then that's up to 16. 12, 13, 14, 15, and 16. So in this direction, we are looking at the input, which is t. It is the age of a child that is 2 years old. T years old. So let's set right here. And then on my other axis, my output is my train fare. So this is my train fare right here. And because my train fare is only going up to $7 and I've got this really tall Y scale, I think I'm going to mark 1 here and then 2. So I'm going to skip a step just to try to fill up my graph a little bit better. You don't have to do this. It's okay if you don't. So my output is y equals 0 if t is between 0 and 5. So think about where t is between 0 and 5 here on my graph. And I am between 0 and 5 in this whole part of my graph. This is where my t is between 0 and 5. So for that part of my graph, I want to graph just basically y equals 0, which is a line right here. And then I've got to think on each end of this little line segment, what kind of endpoints am I making? Am I making filled in circles or am I making open circles? And because it's 0 less than t less than 5, those are both going to be open circles. All right, the next part of this is if the kid is between 5 and 11, right? And let's think about where 5 and 11 is on our graph. So I'm trying to use a different color of highlighter here. So let's use this one. So between 5 and 11 is going to be this part of my graph right here. This might be a little bit dark. This might be kind of hard to read. So on this part of my graph, so again, this is for t being between 5 and 11. T is between 5 and 11. And this is 0 to 5. And then over here would be 11 to 16, right? I've got these 3 different like spots on my graph that I've got to graph. So it says y equals 5 now. So now I would go up to y equals 5 and I would make this graph here. And then let's think about what's going on these endpoints. So it says that I could be equal to 5. So I'm going to make this a filled in circle here. But this one is less than 11, so open here. So it's kind of interesting and it might be hard to read. Maybe you need to go back and erase this a little bit better here. But remember, I have an open circle here and then I've got the filled in circle up here. So when x is 5, remember I only have one value, I only have one output there. Because otherwise, if I have a 5-year-old, how would I know if I'm supposed to pay $0 or $5, right? So it's got to belong somewhere. So it belongs right here where it says at least 5. It doesn't belong here when they said if your kid is under 5. So those are 2 different things. So the last part of my graph is to graph y equals 7 when t is between 11 and 16. So let's go back and get one more color of highlighter here for the last part on my graph. And let's maybe go this little light green right here. A little bit lighter color. I picked purple because I liked it, but it's really hard to read. So this is where my t is between 11 and 16. And now I want to graph at 7. So it costs even more money if your kid is 11 to 16. And again, because it's a less than or equal to 11, that's going to be a solid filled in circle right here. And then on the other end, it's going to be an open circle. I'm sorry, I think you're about to hear my dogs rustling in the background. There's really nothing I can do about it. They're a little bit psycho. So this is my piecewise function. My piecewise function has a little graph for each part of that function. So let's go ahead and go on to the next page. And we're going to take a look at some graphing some more. So these are not as much fun. We do not have to write the equation first. They're not word problems. They just go right into, hey, this is what the piecewise function looks like. Let's go ahead and graph. I think this one would be a really good one to star. This looks like more like the kind of problem that we would expect you to do on a test. So on this one, we are asked to graph y equals 5 if our x is less than or equal to 0. Sometimes I think just looking at this number right here is tricky. So it's just nice to write down the actual function. And we're going to graph y equals x if x is greater than 0. So remember, if I have y equals x, my slope is 1 over 1. And my y-intercept, there's nothing after the x, so my y-intercept is 0, 0. So these are the two functions that I'm going to make. So when I am graphing x less than 0, that's going to be everywhere over here. This is where my x is less than 0. Okay, so I'm going to write above that. This is where my x is less than 0. This is where my x is greater than 0, is over on this side. And let's just put that in a light color as well. So this is where my x is greater than 0. So this function, greater than 0, is going to go on my greater than 0 side, right? The other one would go on my less than 0 side. Okay, so hopefully all this color coding will kind of help. All right, so I'm going to go ahead and graph the part that's less than or equal to 0 first. So this is the or equal to one. So y equals 5 is a horizontal line at 5. So 1, 2, 3, 4, 5. And I only really want to graph this to the left. I'm only going to graph it in the green zone. And because it's less than or equal to 0, this is going to be my solid filled in circle. The next one, I'm going to graph only on the blue side, and my y-intercept is 0, 0. That's where I'm starting, but it says greater than 0. So I'm going to start with an open circle, and then I want to move up 1 over 1 and graph a bunch of points. So it is a function. It's defined everywhere along my x-axis. I do not have two different outputs at 0. It still passes the vertical line test because I have a filled in circle here, but an open circle here. All right, on our last problem. So this one's got 3 different parts again. This one's a lot trickier, a little bit less like something that you would see on a test or quiz. So now we've got 3 different parts. We've got something happening where x is less than 2. We've got something happening basically between 2 and 5, and we've got something happening when x is greater than 5, right? So let's look at these 3 different regions here. So if our x is less than 2, it's y equals negative x plus 1. So my slope is negative 1 over 1, and my y-intercept is 0, 1. So I'm going to go ahead and let's see, x is less than 2. So here's 2 on my graph. So when I say x is less than 2, I'm looking at everywhere to the left of that. So I'm looking in this green zone right here. So that's when I'm going to be graphing this function. So let's go ahead and graph that right now. So I would want to start it at 0, 1, and my slope is negative 1 over 1. And when I get right up to this boundary between the green and whatever color I use next, it says less than 2, not or equal to. So this is going to be an open circle right here. All right, now for the middle part, that's going to be between 2 and 5. So let's pick a different color for that. So 2 to 5 would be here, just in this little strip right here. This is from 2 to 5. And from 2 to 5, I am graphing, let me grab a pen here, I am graphing y equals 2, because there's a 2 right here. So I know that's going to be a horizontal line at 2, because it's a less than or equal to and another less than or equal to. I'm going to have 2 solid filled in circles. So I need to go up to 2. So here's a line at 2, a horizontal line. So horizontal line. And on both ends of this, I need a solid filled in circle. And I'm trying to make them really obnoxious so you can see them through all the color. All right, now we have one more rule for when our x is greater than 5. Not or equal to, but just greater than 5. So that's where my 5 region would be. So let's go ahead and color this in. So for our last graph, we have y equals 2x minus 6. And remember, this is going in our blue zone at the end. And this one's the trickiest because I can't really start it at the y-axis and graph, right? I can't start down here at negative 6 because I don't want it to be where I have green or where I have yellow. I want it to start all the way over here. I want it to start somewhere where x is greater than 5. So what I want to do is I want to substitute 5 into this equation for x. So y equals 2 times 5 minus 6 is 10 minus 6 is 4. So I know that 5 comma 4 is a point on the line. And let's remember that my slope is this 2 over 1 up here. So I want to go to 5, 4. So 1, 2, 3, 4, 5, 1, 2, 3, 4. And I'm going to make an open circle because it says greater than 5, not equal to. So rather than starting at 6 way down here and having to count up 2 over 1 and keep doing that in zones where I don't really have that graph, I've started it at 5, 4. And then from here, I'm going to do an up 2 over 1 to the right slope. All right, so main ideas today were this idea that we could have a piecewise function that has different rules for different parts of the domain, that we could write a piecewise function given a word problem, and they're a little bit tricky, and then trying to be able to graph one as well. So I warned you that on a test, I think a problem like number 2 is really what we're looking at, where we're kind of breaking things apart at 0. I think that's a lot easier. But your practice is going to be a lot more difficult. Your practice is going to have these different regions like we did on B, where we have to play around with and try to graph all of them. All right, so as always, if you have questions, please ask them in class.